This is the 2420 Data Structures class, and we're continuing on with our binary tree class, our B2 tree class. And in this video, we're going to code the constructor and the destructor. So my constructor, as we know, B tree. I do have to have my template on there too. So on the constructor, the constructor is going to be super easy because all I have to do is delete or set my private variables, my protected variable, my root node, and I'm going to set it to null pointer, because if we're going to create an empty tree, all we have to do is set our root to null pointer, and then it knows that the entire tree is empty. My destructor is going to be a little bit more difficult and time consuming. And the reason why is because, let's show you. Here is a binary tree. If I want to delete this node, I can't because it has children, and all of this memory location would be lost if I just deleted this node. It would be kind of a memory leak. So before I can delete this one, I have to delete all of the children, starting probably with this 5 over here, and we'll show you why in just a sec. So in order to do that, I'm going to use recursion. So here I've got my constructor duplicated. I'm going to change this one into my destructor and get rid of the contents of the code. And I'm going to come up here and I'm going to create a helper method, a private helper method called destroy. And all that is going to do is it's going to destroy the current node, or delete it. Guess I could have called it delete, but I think I have another delete coming. So I'm going to create a pointer to the current node, and it's going to delete just the current node by deleting all of the children to the left and all of the children to the right. That way, in my destructor, all I have to do is call this destroy method at the root level, and it will destroy the entire tree. That's why I didn't call it delete, is because it destroys everything below it instead of just the current node. And usually when you have a delete, it just deletes that current node. This is destroying everything. Alright, so I do need to code my destroy. So I'm going to say void b tree type : destroy node type star current. Okay, when we're destroying the current node, we have to see if that node exists first. So if our current node is not equal to null pointer, then I can delete it. If it is equal to null pointer, then that's our base case. It's going to get out of our recursive case. It's going to stop. It's not going to try and delete anything because it's already found that there's no data in this item. It's already null. Alright, so before I can delete the current pointer, I have to destroy. I called it destroy on purpose because it's deleting everything underneath it. So I have to destroy everything to the left, and I have to destroy everything to the right. Once I've destroyed everything to the left and everything to the right, I can delete my current node. There we go. And the way this works is it comes in here and we call this destroy method at the root level, and the root level says, hey, destroy everything to the left, and it comes here and calls this method for destroy at the left for this 6. Well, it's gonna function call for destroy at this level is going to call this one, and then so this is going to say, okay, there's nothing to the left, and then it's going to destroy to the right. Well, then it calls destroy for this method. There's nothing to the left, there's nothing to the right, so it can actually delete this node. And since it's in recursion, it's already called at this level, at this 4 level, it's called destroy to the left. Now it's going to call destroy to the right, which has already come back from that, and it can delete this node. Then it will come back and do the same thing. It's already called to the left, it's going to go to the right and delete all of these nodes. Then it will delete the current node. And that's how this recursive solution to destroy our entire tree works. We'll catch us in the next video, and we will show you how to code the insert method.